The system of equations is shown below. Determine the unique solution to the system when a is 2. So if a is 2, we have x plus 2y plus 3z is equal to 1. Y plus 3z is equal to negative 1. And negative y, now if a is 2, this is 0. If a is 2, this side becomes 4. So negative y is 4. So call these 1, 2, and 3. And 3 gives us that y is negative 4. Substitute in 2. Negative 4 add 3z is negative 1. So 3z equals 3 and z equals 1. And then substitute that into 1 and we get x minus 8 add 3 is equal to 1. So x minus 5 equals 1 and therefore x is 6. So we get x is 6, y is negative 4 and z is 1. We now want to determine the values of a so that the system has an infinite number of solutions or has no solutions. Now an infinite number of solutions will be a situation when we get 0 times z is equal to 0, and z can be absolutely anything there. Now it doesn't have to be z, it could be y or x here. And over here would be 0z equals something which isn't 0, in which case there's nothing that z could be. Now, if we look at 1, 2, and 3, here 2 and 3 are really good to work with, because if we just do 2 add 3, we immediately get rid of y. And we've got 3z add a squared minus 4z. If we add this side, we get a plus 1. Simplifying on this side, we've got z into a squared minus 1 is a plus 1. And so z into a minus 1, a plus 1 is equal to a plus 1. Now, if we take z equal to 1, actually let's take it equal to negative 1 in this part of the question, so z is negative 1, then we get 0 times z is equal to 0. So if we have a equal to negative 1, it wasn't z equal to negative 1, I'm not thinking clearly, has to be a is negative 1 there. So if we have a equals negative 1, we get the situation for the infinite number of solutions. If we take a equal to 1, then we get 0z is equal to 2, and that's our situation for no solutions. So when a is 1, we get no solutions.